We're now going to look at L'Hopital's rule of an indeterminate product. So we want to find the limit as x goes to 0 from the right of x squared times natural log of x. Now you might wonder why we're taking the limit as x goes to 0 from the right, but if we think about the domain of this function of x squared natural log of x, we remember that the domain of natural log of x is every number bigger than 0. We can't include 0, so we have to come from the right, from bigger, and we can't actually take the limit at 0. So if we think of plugging 0 in, or the limit of each of these pieces, the limit as x goes to 0 from the right of x squared would just be 0. And then we're multiplying by, if you kind of look at a graph of natural log of x, as you go to 0 from the right, it's going to negative infinity. So this will work, this method is when we have 0 times infinity or 0 times negative infinity. Now, the little trick we do here is using the fact that x squared is equal to 1 over x to the negative 2. Now, this might seem really crazy to you, and it is a little bit of a trick that we're going to use to help us here. And the way you can kind of see this is true, that 1 over x to the negative 2 is the same as 1 over x squared. And if we were going to simplify that, we would take 1 times the reciprocal of 1 over x squared, which would just be x squared. So we see that we get back just x squared, that these are the same thing. So we're going to take this 1 over x squared and plug it in for this, x to the negative 2, and plug it in for the x squared. So this gives us the limit as x goes to 0 from the right. So we'll have 1 over x to the negative 2, and then we still have this natural log of x up top. Now, if we think of plugging in 0 from the right here, we get negative infinity over infinity, so we get one of our indeterminate forms. So now that it's in one of our indeterminate forms, that's 0 over 0 or an infinity over an infinity, we can apply L'Hopital's rule. And when we apply L'Hopital's rule, we get the limit as x goes to 0 from the right of 1 over x over negative 2 x to the negative 3. So now, kind of off to the side again, we want to figure out what is that equal to. What is 1 over x over negative 2x to the negative 3, which would be the same as negative 2 over x cubed. Remember, when we divide by a fraction, we multiply by the reciprocal, so we'd get 1 over x times x cubed over negative 2. And if we simplify that, we get x squared over negative 2. So we're going to plug that in for this whole thing after our limit. So this limit is equal to x squared over negative 2. So we applied L'Hopital's rule, then we just did a little algebra to simplify what was after our limit. And now, plugging in our 0 here, we get that this limit is equal to 0. So the original limit that we were trying to take is equal to 0. That would be our answer.